I want to ask for your indulgence from the very start, because I'm going to talk about physics, basically, the architecture of the universe. And there will have to be a few $2 words, but I promise there won't be many. But there are some very big numbers, and there's no way to avoid it because it's the essence of the presentation. So they're the same numbers you deal with every day when you're doing a dope deal or balancing your checkbook or whatever. Just bear with me. It's nothing very complicated. I'm pretty much of a die-hard, dyed-in-the-wool doper, and have been since I was about 6 years old. And I also turned pro at a very early age, at about 23 years old. And I've often been asked, what do psychoptic drugs do? What do these visionary drugs do? And generally, of course, by people who have never tried them. And as others have said today, the experience is ineffable, and so it's not easy to put into words. Sasha Shulgin used to say, and he was an inveterate joker like I am, he used to say, they don't do anything. Rather, they permit you to do something or to discover some capability that you didn't know you had. And I agree entirely with that, but it's not a very illuminating answer to the question. Richard Evans Schultes was not an inveterate joker, but he was a very excellent teacher, and he loved to make his students laugh because it's a very good pedagogical strategy. And so one of his laugh lines in his lectures and so forth is he would say, well, you know, they call these things visionary drugs, but I've never really seen a vision. All I ever see are little wavy lines. And I also agree entirely with that. I've never seen a vision. I would love to, in the sense of a substantive being, aliens, gigantic insects, whatever. I would love to see that, but it hasn't been my experience. And so the best answer I can give to that question is that they enable me to perceive the universe, the world, more as energy and less as matter. And then with a pause and an ellipsis, the way it really is, as far as I can tell. And that's a quote from Richard Feynman. And that's what I'm going to talk about. Seeing the world as energy and not as matter, and that in fact that is a more realistic perception. That's the way it is. And first I will just give a brief quote from Max Planck, which says the same thing. This is almost 100 years ago. There is no matter as such. It exists only by virtue of a force bringing the particle to vibration and holding it together in a miniature solar system. And we will discuss this in some detail. Another quote by way of introduction, and this is not only do I ask for a little bit of indulgence on terminology and big numbers and so forth, but William Blake said, he who does not imagine in stronger and better lineaments and in stronger and better light than this perishing eye can see does not imagine at all. So I'm going to ask you to take my hand, and we're going to try and go beyond seeing into perceiving what's behind what we see. So this is not a flight of fancy or a satisfying literary device. What we see as a material world really is a perception of energy. And I'm going to illustrate that by two facts, and these are not opinions or theories. They're simple facts, as I think I can make plain. The first being our eyes, our optical system, the only thing it can see is energy and nothing else. That's the first one. And the second one, the matter that this energy is reflecting off of, whatever is out there, but the seeing is in here, but whatever is out there that we like to think we're getting a faithful representation of, that is more clearly described as energy than as matter in and of itself. So let's go to the first point. that all we can see is energy. In point of fact, the way our sensory system works is the lens in the iris in the front of the eye focus the rays of light, and the image is somehow formed on the retina in the back of the eye. I'm not going to talk about psychophysics, that's beyond this discussion, how that translates into some kind of a moving picture inside the mind, and that's not only beyond the scope of this discussion, it's beyond our knowledge completely. And so what is happening is the electromagnetic force, or electromagnetic energy, is reflecting off of the very external surfaces of objects in the outside world and entering our eye, and that's what we're perceiving. The only way we can perceive it is because energy is entering our eye and exciting cells, photosensitive cells on the back of the retina. If it weren't energy, we wouldn't be able to sense it. And so we cannot see the object itself. We can only see what is reflected off of it. And if there is no electromagnetic energy present, if there's no light, what we call light is just a small segment of the electromagnetic spectrum. But if there's none present, we are, as they say in Spanish, invidentes, we're non-seeing. And so if you've ever been in a deep cavern and shut off any sources of artificial light, you will experience this. There is no visual perception whatsoever. And so it is energy that we are seeing, and only energy. And even if we're looking at an object, a luminous object that is emitting that energy, it's the same situation. We're seeing the energy itself, not the object that's emitting it. And so this is not a novel concept or something extremely original. The fact is now we can put it in very precise terms. But in the 4th century before the modern era, in the famous book, The Republic by Plato in Athens, 2,400 years ago, the famous parable of the cave. And without intending to do so, and in a sense talking about something else, and this would have been way beyond the state of physical science of the day, Plato gave a very adequate model or an analogical description of the physical phenomenon of seeing, of perceiving this energy. In the parable of the cave, and he says it's as though we human beings have always been confined inside a cavern, and they're chained up, and they can't leave it, and they can't even turn around, and they're facing this wall, and there's a source of illumination behind them, either a fire or maybe the opening of the cave in daylight, and so all that they are perceiving are the shadows dancing on the wall in front of them, but they can't see what is ultimately causing those shadows. And so that is a very satisfying description of the way we are perceiving reality. We're seeing spectres, the only wavelengths of light that will reflect off of the object and come into our photosensitive retina. That is what we form the image from. And so Plato had said that the actual object itself, which is beyond our perception, he called ideas or archetypes. Let's see, almost 2,200 years later, I don't know the precise date, around 1770, Immanuel Kant published Critique der praktischen Vernunft, the critique of practical reason. And there he conceptualized the same thing, and he said that the essence that we couldn't see was the thing in itself, Ding an sich. We couldn't see that. We were only, we're experiencing specters, some kind of an image. We like to think that it's a faithful representation, and I'm not going to go into the philosophy of solipsism either, whether there really is something out there or not, because all of this just takes place inside, and the reality and the picture of it is inside. The seeing happens in here, not out there. And of course, if it doesn't pay to think that wall's not there and run into it. I mean, we have a lot of reasons to believe that this outside reality is there and that we get a faithful representation of it. But the fact of the matter is we aren't seeing it itself. We have to have electromagnetic energy present. It has to be sufficiently intensive, and it has to reflect off of it and impact these cells in our retina. And so that's the basic fact, the first fact, that all we can see is electromagnetic energy. Now, let me give you an example of seeing as energy. I'm talking about, well, there's a difference between seeing and perceiving. But in the material sense, in geometrically or spatially, physiologists in general agreement that we cannot resolve below about 1/10 of a millimeter, about 100 micrometers or millionths of a meter. And that's roughly the diameter of a human hair, not the length of a human hair. The diameter of a human hair is, for most people, about the smallest object that can be resolved and discriminated visually, of course, with adequate illumination and so forth. But look at it this way. This electromagnetic spectrum is I won't go into the details of it, but just the fact is what we call visible light is a very short segment of it, only 400 nanometers long, 400 billionths of a meter long, and it goes from 780 nanometer wavelength, the length of the actual waves, and that's what we call the color red, to 380 nanometers, and that's what we call the color violet. And waves that are longer or shorter than that, we cannot perceive visually. The ones that are longer we call infrared, and the ones that are shorter we call ultraviolet. But all of our visual perception takes place over a very narrow spectrum, and it's only 400 nanometers long, 400 billionths of a meter. And, but if you think about this in an energetic sense, physiologists are also in general agreement that we can discriminate about 1 million colors over that very short spectrum of visual light. And so by discriminating 1 million colors over a bandwidth of 400 nanometers or 400 billionths of a meter means we are able to divide it up 1 million times. And how do we perceive that? As color. Color also doesn't exist out there. It's something in here. And we have very good evidence that the hairless apes that shambled and staggered out of Africa some hundreds of thousands of years ago didn't perceive this. The words for colors are very recent in human languages, and they come in a prescribed order. And it looks like it's something that we learned to do. As Sasha Shulgin said, you acquire a capability with what you've already got through these drugs. Something we've learned to do maybe in the last 10 or 15,000 years. But that's not important, be that as it may. The fact is we can discriminate about 1 million different shades, and what those are different frequencies of light. The wavelength is inversely proportional to the frequency. The longer the wavelength, the lower the frequency. And so, again, it's from 380 to 780 nanometers. To give you the numbers, that corresponds to frequencies of 385 terahertz, or terahertz, billions of cycles per second, and 789. It's a very short spectrum. So we divide that up 1 million times, and the higher the frequency, the shorter the wavelength, the more energy they carry. And so what we are perceiving is 1 million gradations of differences in energy, which have a correspondence in physical space. They correspond to a certain wavelength. And so we are able to break down 400 nanometers 400 billionths of a meter, 1,000,000 times. And so that comes out to being able to resolve down to 400 femtometers, or 4/10 of a millionth of a millionth of a meter. And I said geometrically we can only perceive down to 1/10 of a millimeter. So what this is equivalent to is having a 4 billion power zoom built into our retina. We can, if we could resolve in space with our eye the way we can in energy by perceiving these differences in color over this spectrum, we would be able to see 4 billion times better than we can with our eye looking at, we can only see the diameter of a human hair. And so what does that correspond to in the physical world? That's like a 250th part of the diameter of an atom. We could see something hundreds of times smaller than an atom. So there's a very concrete example that seeing, looking at it in terms of perceiving energy as opposed to perceiving matter, we have in fact a greatly enhanced capability, or what we thought of. Okay, time is limited, so I won't elaborate more on that. But so in the first place, all we can see with our eyes is energy, this perishing mortal eye, as Blake called it, and only energy. And so then I said the second point is, okay, I will agree in consensus reality that this table is really here, and what I'm getting in the light rays reflecting off it is a faithful representation of it. And I have pretty good, I'm firmly persuaded, as William Blake said, that is pretty good. And so now I'm going to show that the atoms that make this up are much more logically and clearly perceived as space and energy than as matter themselves. So not only can we only see energy reflected off of matter, but the matter itself is better viewed as pure energy with dotted with little tiny bits and pieces of solid matter than as something solid. So let's look at that second point. So now I need to give you some terminology about the structure of subatomic structure. It turns out that we know 118 elements. There are about 90 that have been found on the planet Gia. I call her Gia, Our Lady Gia. And 26, 28, or no, yeah, let's see, 90, 92. It's not quite clear, but there are 118 in all, and the other ones, the 26, are artificial. They've been synthesized. And so all of them are made from only 3 particles, what we call fundamental particles, and generically they're known as fermions. There are 2 types, quarks and leptons. And the atom itself is made also of 3 particles, but only one of them is a fundamental particle. That is the electron, which is a lepton. So, and the atom is made of protons, neutrons, and electrons, just 3 particles. But the protons and neutrons are not fundamental particles. They're made up of quarks. And electrons can exist by themselves, but quarks cannot, at least not in the present universe. And, excuse me. And they always exist in quark molecules. And we know of at least 2 types, a 2-quark molecule, which is called a meson, and a 3-quark molecule, which is called a baryon. The protons and neutrons are baryons. They're 3-quark molecules. And so the other 2 fundamental particles that make up atoms are the up quark and the down quark, and the electron. Everything is made of just those 3 little bits of matter, and these are the smallest possible bits of matter. And so now we will talk about the dimensions of these things. And you will see very quickly. And don't be put off by the demonstration on the atomic scale, because as I say, they're very big, or rather very small numbers. But I've thought this through very carefully, and I have some models that I think enable most people to apprehend this, to be able to perceive something which is mind-boggling in and of itself. But the basic particles, these fundamental particles, oddly enough, they're the same size. The electron is the same size as these quarks, and that is about 1 attometer in diameter, which is a billionth of a meter, 10 to the minus 18th. And so 3 of these, the electrons are orbiting, the protons and neutrons are confined in most atoms, for practical purposes, are confined in the nucleus of the atom. There's a nucleus, and then there are clouds of electrons orbiting around it. And we use what's called the Bohr Bohr solar system model. Niels Bohr conceptualized this about 80 years ago as a miniature solar system, as the quote I read by Max Planck. It's holding it together in a miniature solar system. And so the nucleus is analogous to the sun, and the electrons are analogous to planets. And as far as that goes, it's a decent enough analogy, but you don't want to look at it too closely. And so the 3 of these billionth of a meter particles, 3 of these quarks, form a proton or a neutron. I should mention there's the up quark, they have fractional charge. The up quark has a plus 2/3 charge, and the down quark has a minus 1/3 charge. And the electron has a minus 1 charge. So 3 down quarks have the same charge as an electron, and 2 up quarks have the same charge as 2 electrons, but an opposite polarity. And so the baryon, or the proton and neutron, is 100 times bigger in diameter than the quark, the 3 quarks that make it up, which is to say it's 1,000,000 times more volume. It has 1,000,000 times the volume of the fundamental particles that make it up. And so 3 billionth of a meter particles go into creating something that's now not 1 attometer in diameter, but 100 attometers in diameter. And so the protons and neutrons, I should mention also, 99.95% of the mass of the atoms is in the protons and neutrons, and it's concentrated right in the center in the nucleus. But the element is defined by how many protons there are. If there's 1 proton, it's hydrogen. If there's 26, it's iron, and so forth. And so the number of neutrons is variable. And at least 1 atom has no neutron. Basic hydrogen is just 1 proton as a nucleus. But the atoms are electrically neutral because for every proton in the nucleus, which again defines the element, there is a corresponding electron orbiting it. And so it cancels out the charge. And because of this curious fractional charge of the quarks, in the proton, you have 2 up quarks plus 2/3 equals plus 4/3, and 1 down quark minus 1/3, net plus 3/3, or plus 1 charge. In the neutron, you have 2 down quarks, 2 times minus 1/3 is negative 2/3, and 1 up quark plus 2/3, and they cancel out. So that has no charge. Very soon, this technical stuff will be over. And it's not difficult, but people tend to, I'm not interested in that, or I never understood it in school, or I forgot it after the exam, or whatever. And so that's the situation. These 3 quarks, the only difference between the proton and the neutron is just 1 quark shifts, and they can transform one into the other, and this happens in nuclear reactions. And elements can move up or down the periodic table in a nuclear reactor or in the sun, which is a nuclear reactor, a fusion reactor. Okay, so you start with the 1 attometer, and then you get 100 times bigger thing, which is the proton or neutron. And then the nucleus is 10 times bigger still, or 1,000 times bigger than the fundamental particles, the quarks, and or 1 billion times more volume. And then it really gets wild, because the diameter of the atom is another 100,000 times bigger. And so that comes out in an actual atom around 100 picometers, or 1 times 10 to the minus 10th meters, a tenth of a billionth of a meter. That's the size of the atom. But note, the important thing to note is the atom is 100 million times bigger than these tiny bits of matter that make it up. Okay, here's my first model, and I'll give you three. Let's assume that the smallest particle of matter is a 1 centimeter pearl. I wish I had one to show you, but I don't. But you can surely visualize that. And so the quarks and the electrons are 1 centimeter pearls. Then the proton and the neutron would be a 1 meter diameter beach ball. And the nucleus would be a 10 meter diameter weather balloon, which could basically almost, pretty much fit in this auditorium. But the atom itself would be like the planetoid series, 1,000 kilometers in diameter. And it would only be made up of 1 centimeter pearls. The only solid stuff in it is 1 centimeter pearls in something as big as the planetoid series, or 1,000 kilometers in diameter. Actually, the series is slightly smaller than that. Okay, later I'll talk about the relative volume of this as it is solid. All right, okay, second model. Since Niels Bohr modeled this on the solar system, with the sun being the nucleus, let's say that the sun is the nucleus of an atom. What would the other particles look like? Okay, so going smaller, if the sun, which is 1.4 gigameters in diameter, if the sun were the nucleus of an atom, the protons and neutrons would be exactly the size of Jupiter, which is 1/10 the diameter of the sun, or 140 megameters, 140,000 kilometers. And 1.4 gigameters is 1.4 million kilometers. And so, so the sun would be the nucleus. The protons and neutrons, which are making up this sun, making up, that combine to make up the nucleus, would be Jupiter's. And the smallest particle, the quarks and the electrons, would be about 60% the diameter of the moon of the Earth, or 11% the diameter of the Earth. But the atom itself, with the sun being the nucleus, here Bohr's model breaks down because there's not enough space in our solar system to extend this atom out. The outermost shell of electrons would be 3 times farther than what we call the heliopause, where the solar system ends. And it took the Voyager 1 probe 40 years, traveling 1.5 million kilometers a day to get there, and so it wouldn't get to where this atom would end until near the end of this century, still traveling at that velocity. And so the Bohr atom with the sun as the nucleus would be 140 terameters in diameter. Okay, one final model, and then I'll put some structure to all this. Let's assume that this planet is the final atom. Trying to make it, the problem is the differences in scale are so great that it's very hard to, you can't make it visible, because even by blowing it up, if we blew it up so that you could see the 1 centimeter pearl, if you were standing far enough away to be able to see the whole 1,000 kilometer diameter atom, you'd have to be several thousand kilometers away. The pearls would be invisible. You wouldn't be able to see them. And so that's why it's intrinsically, it's ineffable. It's not amenable really to visual understanding. Okay, so let's assume that Gia, or Lady Gia, we've blown the atom up that big, and that's about 12.8 megameters in diameter, 12,800 kilometers. Okay, so then the nucleus, which would be right in the center, the very center of the Earth, would be 128 meters in diameter. Let's say a domed football stadium. All of the mass would be in a domed football stadium, a little over 100 meters in diameter, in the very center of a almost 13,000 kilometer diameter planet, the Earth. And so, and that wouldn't be visible from the surface either, if it were all transparent, and so it would be too far away. It would be almost 7,000 kilometers from the surface, this little football stadium that has all the mass in it. And so The protons and neutrons, if the Earth were the final atom, would be the 10-meter weather balloon, or 13 meters in this case, diameter weather balloon. And the smallest possible particle of matter, with the Earth being an atom, would be a 13-centimeter diameter, big, fat, grandfather peyote plant. And I have one that's almost that big. And so the matter would be made up of 13-centimeter diameter peyote plants, and it would be strung out in this gigantic thing as big as this planet, which is very big for us. It took me a long time to get here. Okay, well, I'll make it as easy as possible for a material construction on these data. The largest atom, which has the most fundamental particles in it, is atomic number 118. It was only named last year, and it's called oganesson, OG, and it's number 118. It's the final column, the 18th column in the 7th row. The columns are groups, correspond to the number of electrons in the outer shell, and the rows are how many shells of electrons there are. So we finally filled out the 7th shell of electrons, and now people are trying to make atoms with an 8th shell of electrons, but that will take years even if they succeed. Okay, so in oganesson is 118 atomic number, so it has 118 protons, and it also has 118 neutrons. And electrons, because they're neutral. It happens also, besides in the nucleus, 118 protons, to have 176 neutrons, or a total of 294 nucleons or baryons, the sum of the protons and neutrons, each containing 3 quarks. You multiply that, you get 882 quarks and 118 electrons. It adds up to an even 1,000. And so the largest atom that exists only has 1,000 of these in it. And if the Earth were the atom, the only thing solid in it would be 1,013 centimeter grandfather peyotes, and all the rest is what I call inner space, which is as vast and unfathomed as is the outer space in which the planet is traveling. Okay, I'll drive the point home even more dramatically. So we have only a 1,013 centimeter peyotes making up something that is as big as the planet and concentrating all of its mass, because the electrons contribute a little, but I'm counting the electrons with this. And so if we were to be able to compact them into their smallest possible size, assuming the quarks, you could turn off the charge, because that's the problem. The like charges repel, and that's why 3 quarks take up 1,000,000 times the volume of each quark. The proton has 1,000,000 times the volume of the quark, and it's like a beach ball with only 3 pearls inside, and the rest is space. And this is the solid part of matter. The electrons are even more evanescent, and they're everywhere and nowhere. And so we have only 1,000 of these particles, and if we could confine them all in the smallest possible space, it would be a sphere about this big, about this diameter. Would be everything that would be, sorry, that would be all that is solid. We really don't need a microphone, but shit. Anyway. Okay, so with the whole Earth being a model atom, the entirely solid part would fit in a sphere about less than 1.5 meters in diameter, which one could even shove and lug around, at least if one were Atlas. And so I can drive the point even harder home. Let's talk about the Earth itself and not a model of an atom blown up uncountless numbers of times to make it the size of the Earth. all of these solid particles, if we could, again, confine them to the smallest possible diameter, all of these solid particles that make up every atom on the Earth, on the surface, all the way down to the core, would likewise fit in a sphere about 1.5 meters in diameter. And so that's all that is solid in matter. There is some solidity there, and the mass is much more important than this dimensional stuff, and I'm going to talk about that before I wrap this up. It's very difficult even to conceptualize something. It just doesn't jive with our everyday reality. I mean, you run into something, you bounce off of it and you hurt yourself. It feels really solid, but in fact it isn't. Let's assume that this is a rustic gourd full of ayahuasca on a really rude table in a very nice hut in the Amazon, and so forth. In point of fact, the gourd of ayahuasca is not touching the table. No two things of ordinary matter can touch each other except under extreme conditions. And by that I mean like in a fusion reactor, a magnetic confinement bottle with extremely high magnetic fields and electrical currents, very high temperature, very high pressure, effectively, and confined by a magnetic field. It's been attempted with lasers, but it hasn't been adequately achieved. And so, why is that? Because the surface of the atoms is what defines their external boundary, are these electrons that are whizzing around. And all of the atoms have them, and so they all have negative charges on their surface, and negative charges repel each other. And so this thing sitting on the table is analogous to a magnetic levitation train standing in the station, not moving forward or backwards. It's floating on a field of force, which is like trying to push two poles of a magnet together. And so we can't touch something. What we feel is resistance and pressure, and the same thing with mass, resistance and pressure. But our tactile sense is an hallucination. We are not actually touching anything. And just as we're not actually seeing anything, we're only registering this energy that is bouncing off of it. And so now I said that the mass is, I need to drink something. The mass is more significant than the dimension, because I think I've adequately shown that we're perceiving only energy, and that it's much more faithful representation of reality to conceive of the atom as a space, and all that space is there because of the force fields around these charged particles. The electrons are repelling each other in this vast space around the atom, and the quarks are repelling each other inside the protons and neutrons. And so the model that I gave you with the pearl, the beach ball, the weather balloon, and the 1,000-kilometer planetoid, the pearl is solid. But the rest of it isn't. The beach ball doesn't really have a plastic surface. What defines its surface is where the force field ends. There are two particles that are repelling each other strongly, and another one that's attracting both of them. And there are things which I won't discuss, but they're called gluons, which is by far the strongest force in nature, which confines them in this. That's the smallest possible space that the strongest force in nature can confine these things. But what defines its diameter, or its so-called surface, is this force field around these particles. And similarly, for the nucleus, there's no membrane like in a cell. What defines its diameter is the collective force fields around all of these beach balls without any plastic, these magnetic beach balls. And so, these electron clouds, I mean, they're just everywhere and nowhere. There's just nothing there. Yeah, I've got a timer. I'm going to wrap this up. And so, but I just want to go into the energetic dimension before I do. I wrote it down somewhere. Oh, there it is. Okay, everyone knows at least the famous formula E equals mc squared of Einstein, that mass and energy are interconvertible. So not only have these 2 points that we're perceiving energy, and what is reflecting that energy is more likely described as energy in space than as matter, but what little matter there is, the mass of it, which is concentrated in the nucleus, is convertible into energy, and a lot of energy. And so it means the energy in ergs is equivalent to the mass in grams times the square of the speed of light in centimeters per second, which is 10 to the 10th. And so 3 times 10 to the 10th. And so 1 gram of matter is convertible into 9 times 10 to the 20th ergs of energy. I know that doesn't mean anything per se, but maybe if I convert it into more familiar forms, that's like 3¼ gigawatt hours of electrical energy. So say you have the largest nuclear power plant in Europe, it's like 3 hours production of that. Or it's equivalent to 330,000 liters of petrol. That's from 1 gram of matter. And so also in this sense, this solid part, the mass of the little solidity that the matter has, is an immense quantity of energy, and it can be naturally converted. The sun does it, and there have been natural nuclear fission reactors on the Earth. In Africa, they found a couple of them where critical reactions started just in a very good uranium mine. And so it's something that happens naturally. And before, I just want to conclude with a couple quotes, but I will just say that that's from 1 gram of matter, 330,000 liters of petrol, which is like 275 tons of petrol, many truckloads. And so, and the sun is converting 4.2 teragrams of hydrogen to helium, a mass into energy every second by converting hydrogen to helium. For every kilo you lose 7 grams is converted into energy. And so you run the numbers on the sun, and the sun works out to, it's producing about 343 zettawatts, big Z, big W. What that means is it's 345,000 billion watts. That's why solar energy is a good bet, as opposed to coal mines and so forth. Okay, in conclusion, oddly enough, I said this is not something original, and I just spent a lot of time thinking how I could communicate this or make models that would enable a more facile apprehension, and first for myself, of course, and then to be able to convey it to others. But by some manner, William Blake, who's one of my favorite English writers, writers of all kinds, and this was about 225 years ago. I'm going to give you a couple of quotes from him and conclude with that. He said, and this, note how similar this is to what Max Planck said 150 years later. But first, the notion that man has a body distinct from his soul is to be expunged, and this I shall do by printing in the infernal method by corrosives, which in hell are salutary and medicinal, melting apparent surfaces away and displaying the infinite which was hid. This is in The Marriage of Heaven and Hell, in the second of their 5 A Memorable Fancy. This is in the second one. I should explain, Blake was satirizing Emanuel Swedenborg, who's purportedly visited physically heaven and hell, and it's a pretty brutal satire of Swedenborg. And it's a very playful piece, but it's a brilliant piece of writing, in my mind, unequaled. And he's speaking literally when he's talking about printing by the infernal method by corrosives. Because the very basis of our highest technology, which is the manufacture of silicon microchips, which can be done at a 5 nanometer resolution at the present time, maybe even 4. And that's like twice the diameter of a DNA double helix. We are engraving on silicon plates which are like metal printing plates, but it's a softer metal, features only 4 nanometers across, and that's like 2 times the diameter of a DNA double helix. And that is the very highest manufacturing technology that we have, the finest resolution and so forth, and it's the basis of all of our other highest technology, the chips that go into the computers and all of these other devices. Well, that technology was invented by William Blake. He was an engraver. He had not much formal education. He was self-taught. He was a poor man, and he invented the method of printing by corrosives, in which he would take the metal plate and mask it with beeswax, engrave the design with a stylus or a burin, and then expose it to acid. That's what he's talking about when he's saying printing by the infernal. The very poem in which he says this was printed, he called it illuminated writing, and then he would paint the plates himself. He would paint in everything, the text and the illustrations. And so it's amazing. Blake can see that. And I forgot one other thing that I wanted to mention, a little John Bullism here. It happens that these subatomic particles, the proton, the neutron, and the electron, they were all discovered in England and in the same laboratory, the Cavendish Laboratory, by Thomson, Rutherford, and Chadwick, and from 1897 to 1932. And it wasn't until Chadwick discovered the neutron that anybody could make any sense of the periodic table or even start to make a real theory of chemistry. The atomic weights didn't make it, and nothing made any sense until the neutron came into the picture. Anyway, now I want to close with 2 other quotes from the Marriage of Heaven and Hell. This same second A Memorable Fancy actually doesn't continue, but starts with this. The prophets Isaiah and Ezekiel dined with me, and I asked them how they dared so roundly to assert that God spoke to them, and whether they did not think at the time they would be misunderstood and so be the cause of imposition. Isaiah answered, I saw no God, nor heard any in a finite organical perception, but my senses discovered the infinite in everything. And the poem begins with what's called the argument, but the real beginning is called The Voice of the Devil. And this, in my mind, Blake intuitively had prefigured this view of the universe through subatomic physics and, to a certain extent, chemistry. And that goes as follows. All Bibles and sacred codes have been the sources of the following errors. 1, that man has 2 real existing principles, these, a body and a soul. 2, that energy, called evil, is alone from the body, and that reason, called good, is alone from the soul. 3, that God will torment man in eternity for following his energies. But the following contraries to these are true. 1, man has no body distinct from his soul, for that called body is but a portion of soul discerned by the 5 senses, the chief inlets of soul in this age. 2, energy is the only life and is from the body, and reason is the bound or outward circumference of energy. 3, energy is eternal delight. And the actual title of my talk got truncated. It was, if energy is eternal delight, what about matter? And with that, I will conclude, and I think I've used up my time anyway. Thank you for your attention.